Our next topic is knocking. What is knocking? So, in general terms, this means knocking, right? So, knocking occurs in internal combustion engine, so IC engines. So, knocking occurs in petrol engine, knocking occurs in diesel engines also. But knocking with respect to petrol engine is different from knocking with respect to diesel engine. Let us see how these both are different. So before going to diesel engine, let us discuss what is knocking with respect to petrol engine. So before discussing what is knocking, let us understand the working of IC engine. So the engine runs, or a vehicle runs, with four steps. So IC engine works with four steps. The first step is suction step. The fuel air mixture will be sucked into the engine. The second step, so in the first step, what will happen? The engine will have two valves. You can see here there are two valves. So these are the two valves here. It will have two valves. One is the inlet valve, other one is the outlet valve. So in the first step, the outlet valve will be closed. You'll have the inlet valve. Okay, inlet valve will be open. In the first step, fuel air mixture will be allowed inside. Okay, and once the fuel air mixture is allowed, both inlet and outlet valve will be closed. The second step, the fuel air mixture will be compressed. In the third step, a spark will be produced. And in the fourth step, the fuel undergoes combustion and piston will move upward. So this is smooth combustion. If this occurs, there is no knocking at all. Then why does knocking occurs? This is the question. So let us see why knocking occurs. So the chemical reactions, we'll discuss that later. Let us see practically why knocking occurs. So once again here, what is the first stroke? In the first stroke, the outlet valve is open. The inlet valve is closed. The inlet valve is open. So here, in the inlet valve, what happens? The fuel air mixture is sucked in. The outlet valve and inlet valve both are closed. Okay. So what will happen? The fuel air mixture is compressed by the piston. When the fuel air mixture is compressed, so know that pressure increases. So pressure is directly proportional to temperature. When pressure increases, temperature automatically increases. So what is the third stroke? In third stroke, spark should produce and fuel should get ignited. But before going to the third stroke, in the second stroke itself, in the compression stroke itself, part of the fuel will get ignited. So when the fuel gets ignited, what will happen? The fuel produces some gases. The fuel, instead of decomposing to carbon dioxide and water, it will decompose to give some of the intermediate gases. So since the outlet valve is closed, these gases will hit the inner walls of piston and engine, producing a rattling noise. What noise? Rattling noise. It is called as knocking. So these gases should come out, right? But the outlet valve is closed. When will this outlet valve will open? It will open only in the fourth stroke, but it is closed here. So what will happen? This will hit. So you see the gases are hitting. So it is hitting, right? The gases are hitting the inner walls of engine and piston. So this is called as knocking. So this is why either in two-wheeler or four-wheeler or six-wheeler, whether it is your or automobile, any automobiles, which is a two-wheeler or a car or auto, right? You will get that sound, unbearable sound. That is called as knocking. This is the practical thing. So let us see what are the gases emitted. Okay, let us see. So what will happen? So there is something called as compression ratio. So what is compression ratio? Compression ratio is nothing but the ratio of fuel and air mixture before and after compression is called as compression ratio. Okay, the ratio of fuel air, the ratio of engine before and compression of fuel air mixture is called as compression ratio. As the compression ratio increases, the efficiency of the engine also will increase. So beyond some threshold, beyond certain threshold explosive combustion occurs, what I have told you, right? So due to this explosive combustion, it will produce some thermal shock waves, and these waves hit the inner walls of engine and piston, producing a rattling noise known as knocking. Thus, knocking is defined as production of rattling sound, result of explosive combustion of fuel air mixture due to increasing of compression ratio. So let us see the mechanism. So if you let us consider ethane as the fuel. So ethane on combustion gives what, carbon dioxide and water. It is normal combustion. So the same ethane, if it undergoes explosive combustion, what will happen? So ethane on, when it mixes with oxygen, it gives ethane peroxide, right? Dimethyl peroxide. So this dimethyl peroxide, what will happen? That is, this occurs in the second step, I mean the explosive combustion. So what happens here is, so this dimethyl peroxide will decompose to give some intermediate gases, acetaldehyde. This acetaldehyde once again decomposes to give formaldehyde. This formaldehyde finally decomposes to give carbon dioxide and water. So this acetaldehyde or dimethyl peroxide or formaldehyde, so what will happen? This want to go out. Since the outlet is closed here in the engine, the outlet is closed, exhaust is closed. Okay, it will open only in the fourth stroke. So since it is closed, what will happen? It will hit the inner walls of engine and piston with high pressure. Okay, because of this, we get a rattling noise. Okay, that is called as knocking. And why this occurs? Because as pressure increases, temperature also will increase. Okay, so now, okay, so what if this is there? So what will happen? What are the ill effects of knocking, and how to prevent knocking? Let us see. So this is what knocking is. So knocking. So this knocking, so the sound, this rattling noise, it produces undesirable rattling noise. So due to which the driving becomes uneasy. It is irritating noise, right? So the power output of the fuel is decreased, and because of knocking, inner parts of engine will be damaged. Since it hits with high pressure, the inner parts of engine will be damaged. Okay, and it increases the fuel combustion and decreases the efficiency of the engine and also the power output. So these are the adverse effects of knocking. Now, how to prevent this knocking? This is the main question, right? So let us see how to prevent knocking. So by using critical compression ratio, we can minimize knocking. So you are supposed to use a critical compression ratio. By using critical compression ratio, we can minimize knocking by reducing inlet temperature. The fuel air mixture, when you are letting into the IC engine, so by reducing the inlet temperature and pressure of the fuel air mixture, we can minimize knocking. So by retarding the spark, lowering the output, also we can reducing the knocking. So other main thing is, we can, by using high octane rating. So you have octane rating. The octane rating of the fuel which you are using in India is 75 to 80. So in European countries, in Western countries, 90 to 95, right? So if you use high octane rating fuel, the knocking will decrease. So octane rating is inversely, knocking is inversely proportional to octane rating. As octane rating increases, knocking will decrease. Okay, and also using anti-knocking agents. So by using certain anti-knocking agents, we can prevent knocking. So I have discussed what is knocking and what are the adverse effects of knocking and how to prevent knocking. Now next session, so we will discuss in depth about anti-knocking agents. Thank you.